Hey, physics class. I'm trying out a new format. I'm going to see what I can do with the new camera angle. So you've got a face up here in the corner so that you've got something to look at when it's just talking, attach a face to the voice. There's a graphing calculator over there for you to follow along with the work that I'm doing so I don't have to write everything out longhand and do it in my head, just talk about the math I'm doing. I also have this workspace down here, and that's where I'm going to be doing the work, showing the work that I'm doing, and yeah, let's just see how this goes. I'm going to do a sample problem, and this should set you up for Wednesday's work. So here I go. If I were to have a start and an end, just trying to make sure I can stay in frame. All right, good. So I got a start and an end. So I'm going to go ahead and color each of these because I want them to be as visible as possible so they can just pop. You know what I mean? Got to be all graphical with these. So I'm going to draw a fairly simple network of resistors, and then I'm going to work through how to solve it and simplify it down to a single equivalent resistance. There's one, and let's do the blue. You can tell those apart, right? Hopefully they're not too close. And let's do O. It's a good color. Guess I'll go with this one. There we go. So, labeled. I guess I can call this R4. Oops. By the way, whenever I'm labeling resistors with an R and a number, I cannot help but think of Star Wars droids. And I guess you can just test to see for yourself if it works for you, because here's R2. R2! Alright, so there we go. 4 resistors in a circuit. We're going to break it down into equivalent resistances. I'm going to redraw this in stages as it gets simplified, and we should be able to work them out. But of course, before we can do this, I need values for them. So let's just make these kind of simple. Let's say this R1 can be 1.1 kiloohms, 1,100 kiloohms. By the way, having colors also really helps, because if it gets really cramped, you can tell what writing goes with what picture. R2, let's go ahead and have that be 900 ohms. R3, I can't even tell that's a 3. R3, would you please be 2.1 kiloohms? It's 2.1. And R4, you can be the biggest one. You can be 3K. All right, so we've got 4 resistors in this circuit, 1.1 kiloohms. R2 is 900 kiloohms. R3 is 900 ohms. R3 is 2.1 kiloohms, and R4 is 3 kiloohms. All right, so let's just talk about things, whether they are in series or in parallel, and do you have to go through them both, or can you choose? So I'm going to put it like this. I'm going to do a little table. It's going to go and versus or. Okay, so and or, those are going to be the choices. How does this work? Well, is it that you have to go through R1 and R2? Or is it that you could go through R1 or R2? Well, you do have to go through R1. There's really no getting away from that. However, you don't have to go through R2. So this is going to be an OR. You don't have to go through them both. You could go through R1 or R2. That one's a little tricky because you have to go through R1, but you don't have to go through R2. So you do have a choice concerning R2. All right, so let's do that again, but with R2 and R3. Do you have to go through them both? Well, you don't actually have to go through either one. However, if you go through R2, you must go through R3. There's no getting away from it. That's an and. All right, let's just do one more of these. How about R3 and R4? Do you have to go through them both? If you go through one, must you go through the other? Well, turns out you can't go through them both. You must choose one or the other. These are definite or. Okay, so I'm going to take this picture as assumed, as in you know it. Maybe you've drawn it, or if you forget what it is, you can pause and go back to it because I have limited space and I can't keep it up indefinitely. So a good way for you to follow along with this kind of thing is for you to take notes, draw these things so that when I move on to a new slide, you have what you need, okay? So I'm going to go ahead and get some space here and we can continue. So I've got some that can be simplified, and the first thing that can be simplified is I can take resistors 2 and 3 and combine them into one. So our new circuit is going to look like this. We still have R1. That hasn't gone away, and it is still 1.1 kilo ohms. Now we've got the split, and this is where things are different because I don't have an R2 and an R3 anymore. I have the equivalent resistance of R2 and R3. So I'm going to go ahead and draw that one, and I'm going to let's see, I had two colors that were kind of similar. I'm going to see if I can drop a marker. I'm going to see if I can use them both. So this is just one big resistor. Okay. You know what? Maybe I should be making the combined ones black so I don't confuse the issue with colors. This is the combination of resistors 2 and 3. Now, resistors 2 and 3, were they in series or were they in parallel? Well, clearly they were in series because if you go through R2, you must also go through R3. And the two values were 900 ohms and 2,100. So 900 plus 2,100. That's 3,000. Oh, you know what? 900 plus 2,100. There we go. It's 3,000. So we've got this one resistor here. It's now a 3K. Speaking of 3K, there was another 3K in the neighborhood. Right here. Resistor 4 was also a 3K. So just so everything is, on the up and up, we're all clear. Oh my gosh, on the up and up. All right, so just so we're all clear, This circuit has 4 resistors, 1, 2, 3, and 4. 2 and 3 are in series, which means that they work together in a way that we can calculate, and we can replace resistors 2 and 3 with a single resistor with the same effect. So we are almost like following the order of operations and simplifying something so that the entire thing is the same, but it's now expressed in a way that's a bit simpler. Okay, well now what do we have? We've got a resistor 1, and then we've got a split. And the 2 paths on this split take us to 2 that we could go on one or the other. So these 2 resistors, they are in parallel, and the way that we are going to add them is according to that formula where the reciprocal of the answer is equal to the sum of the reciprocals of each resistor. I'm going to go ahead and write that equation once just because it's complicated, but this should be something that you have in your notes already. 1 over the total resistance is equal to 1 over the resistance of each one added in reciprocal. Okay? So that means if I want to find the equivalent resistance of these 2, I'm going to need to do this in the calculator. Oh, there we go. Okay. 1 over 3,000 plus 1 over 3,000. Right, so that's 1 over 3,000 plus 1 over 3,000. But that's 1 over the answer. So one more big parentheses, 1 over, well, this. Okay, so if you want to make it a little easier on yourself, you can start the whole problem with a 1 over. Anyway, 1 over, or the reciprocal of the sum of the reciprocals. English and math, they don't mix, do they? Just look at the equation as written on paper and on the calculator. The answer is 1,500. Okay, so that means I can redraw this to only have 2 resistors. So out of here, first paper. Here we go, second paper. Well, out of here, second paper. Here we go, third paper. All right, so away with you. Yeah. All right, I think I know what I need to do for next time. I need to make this a wider angle. Noted. So, oh, right. Got to draw that circuit. There we go. Start and finish. We still, well, that was a nice straight line, Mr. Estes. We still have a resistor 1. That hasn't changed, and resistor 1 is still 1.1 kiloohms. And then we got this other equivalent resistor. This resistor is a combination of 2, 3, and 4, and it's equal to 1.5 kiloohms. Okay, well, these 2 resistors are in series, so the problem has just become very easy. You just have to add those 2 numbers together. 1.1 plus 1.5 is 2.6. I mean, did I really need the calculator for that? Yes, I did, because I'm tired. So 2.6 kiloohms is the equivalent resistance for this whole circuit. Okay, well, I've got a change to make to this setup. Like I said, I need to make this a wider angle. I also need to check the footage down here and over on the calculator to see if I like screwed it up or something. I've also had the microphone over here. I think I might need to put the mic over here so I don't get quiet when I go to do the calculator. Do you know what I mean? Anyway, this is my first draft. So How'd I do?